Hello everybody, welcome to Blue Marble Science. We've got your gas pressure without a container. It's right down there. See? There it is. You know, we keep hearing this over and over and over again. You can't have gas pressure without a container. At least according to Nathan Oakley, Quantum Eraser, Anthony Riley, and I guess pretty much every other flat earther out there. But you know what? They're wrong. So Gladys, are you ready? Atta girl. Let's light this dumpster fire and have some fun. Okay, so what's the issue? Well, it's really simple. Flat earthers can't afford to have gravity become a real thing, because if that ever happens, most of their argument just flies out the window. They can't have gravity be responsible for retaining our atmosphere. They just can't have it. That would cause our atmospheric pressure gradient, but that would also mean that the atmosphere simply diminishes into the vacuum of space. Space is real, their dome isn't, and their argument is done. Now, unfortunately for them, it's actually pretty easy to disprove that nonsense, and we've done it. The first part of this demonstration was done a few weeks ago in the shop and included in another video, and I'll put a link for that in the comments. But now I've taken it outside where I can demonstrate a much higher gas pressure with a taller pipe. So just to go back through the original video very quickly, we did this per the Nathan Oakley scientific method. I went through the observation and hypothesis and variables and all of that stuff. And basically, what we ended up with was an incline manometer, a 4-foot piece of pipe that we could fill with butane and measure the gas pressure without a top on the pipe. So gas pressure without a container. After that, we did a little mathematical predictions and some analysis. Here's what we were predicting. And I'm going to go ahead and play that original video, and then we'll come back and review what we saw. And then we'll get into the more, the higher pressure measurements that we made earlier today. We're going to demonstrate gas pressure without a sealed container. This is the little arrangement that we see the cartoon of in the slides. Piece of 1/2-inch pipe, which is 4 feet long, an incline manometer, and this thing reads air pressure simply by this red fluid that's in the tube. Right now, I'm going to reset this a little bit to show 0 pressure. Right there. And as you can see, got a valve on the bottom, but we're not really going to use it. And that thing may still have a little bit of butane in it, so let's just make sure. There we go. So 0 pressure up here. 0 pressure down there. There's no pressure in the system at all. I've marked the pipe at 12 inches, 24 inches down from the top, and I'm going to be setting this right here even with about the top of where that tubing is, because that's the height of the column of gas we're measuring. And then there's a final one at 36 inches, which is up here just sitting, it's actually 38 inches with everything just sitting up like that. So there's a 38-inch mark right there. Okay. I'll drop this back down. I'll let it just sit there for a minute. we're going to put butane in this pipe. And I found out the easiest way to do that is just through the tube. So let me squirt a little bit of butane in here. Okay. You might actually be able to see the vapor come off the top. I need to keep this up at the same elevation. Let me let this, it's very cold when it goes in there. So let me let this just equalize just a little bit. Seems to be nice and full of butane. Now I'm going to connect the hose back to the high pressure side of the manometer. Make sure we're sitting on 0, and we are. Right on it. Now let's raise this pipe up to the point where we're at about 12 inches. More or less like that. Now you can see that the manometer is reading about I'll call that 1.5 or 0.15. Let me get that right. 0.015 inches water gauge. Let's go to the next reading. At 2 feet. We're reading 0.03 inches water gauge. And now the final reading, I'll take the pipe all the way out of the vise. And now let's see what we're calling that. That looks like I'd say about 0.48. Let me put this back down to let's take this loose. Now, did we come back to 0? No, we didn't. Didn't quite come back to 0. So let's re-zero the instrument like that. One more time. 12 inches. It's about 0.013. Second one, it's about 24 inches. .026. And the final one. That shows 0.04. No, about 42. 0.042. Yeah, we came pretty close, pretty much back to 0 again. Actually slightly low. I'm gonna do one more time. And then we'll have 3 sets of numbers we can use. Go to 12 inches. One, 3 again. 0.28. And the final one at 4.2 again. So there's our numbers. Now, get the gas out of it. 0. There you have it. A pressure gradient, gas pressure, and in an open container. All right, so after we did that, we ended up with this set of numbers, and you can pause the video and review all this yourself. But it all matched very closely with what we had predicted. But again, we only had a 3-foot column or 38-inch column of gas to measure. So next, we're going to go outside and do some tests with some taller pipes and see how that works out. We did this experiment in the shop using the 4-foot piece of pipe you see there. But that was limited just by the height of the ceiling in the shop area. So that's what limited how much pressure we could generate. So we've got the incline manometer back out here on the back porch now. We're going to try this again. I've got a 10-foot piece of PVC pipe. Let's see if we can find the top. There's the open top of it up there. And I've got a coupling on the bottom of it that'll screw on the top of the 4-foot pipe. So first, I'm going to pressurize just the pipe alone. And we'll see if we get a reading that's more or less comparable to what we had in the shop previously. Okay, so let's see here. Same as before. I think we're pretty much full. And there we go. Very much like we had before. There's about 0.045 or so inches of water gauge pressure. And of course, the large brown animal there is my laboratory assistant. What do you say, boss? So let's get the pressure out of the pipe. That should have emptied it out. Let's see if we've got any pressure left in it. Nope, 0. All right, next, I'm going to screw this piece of PVC on the end of this thing, if I can. Alright, it should be tight enough. We're not doing a long-term pressure test here. So now, let's check again, see if we have any pressure. Nothing. Still reading 0. Now let's see if we can fill this thing up. Alright, shut that valve off. Let's connect the hose up to the high pressure side. Whoa. Now you can see, looks like close to 0.23 inches water gauge, something like that. Let me take this off. Leave it off for about 10 seconds or so. Let's see what it does now. See, it's dropping. We're just draining the butane out of that pipe through that tiny little hose. I don't know if you can see this, but I can see the vapor coming out of it. Like so. So that's a pretty long piece of pipe, and this is a tiny little hose, so it'd take a while for this to come all the way back to zero. Let's see what we got. That's taking it down to 0.14. Alright, I'm going to repressurize it. We'll take another look at it. Pretty much the same, 0.23. Might not have gotten it completely full that time. A little bit more in it. Yeah, 0.22, 0.23, somewhere in that range. I got another 10 feet of pipe, but I'm not sure I can make it work. We may try. If so, we'll be back. If not, there's 0.2 of an inch, which is roughly what 5 times what we had before. And then that makes sense. The pipe is a good bit longer than we had. Okay, now for the final pressure without a container. Wind's picked up a little bit, so, and you can actually maybe see the manometer fluctuate slightly. That's just wind blowing across the top of the pipe. But now we've got 20 feet of pipe on it, all the way up to nearly the top of the chimney. Well, that's 20 feet of PVC plus 4 feet of cast iron or steel pipe. So all right, same deal, no pressure, I'm going to take the butane. Let's try filling that whole pipe up. See how we do. Got no idea how much we got in there. We will try it and see. Alright, this is indicating 0.35 inches. You see 0.35. I'll try getting a little bit more in there. Oh, not that in.
I'll stop.
Yeah, that may be about all we can do. 0.35. So, pressure without a container. .35 inches water gauge. "20 feet of open pipe." We'll let it sit for a while and see what it does. Well, it's been well over 3 hours now. Our gas pressure is still sitting here quite happily. You'll notice a slight variation from time to time. The wind is blowing a bit, but it's exactly where we left it for all intent. No difference. This thing would sit here like this, well, as long as you wanted it to, until it rained or something like that. There's the pipe. Hopefully you can see the top of the pipe. Let's see if I can zoom in a little bit. There's the top of the pipe. Okay. And just to be sure that's real, we'll take the pressure line off. And the manometer goes back down. It's warmed up a little bit, is what's happened. So it's showing slight pressure. Let's take that. I've let a little bit of the gas out, but so there you go. Gas pressure without a container. Well, let's talk about results. Obviously, this test was not done under highly controlled laboratory conditions. If it would have been done for the specific purpose of trying to get actual, very accurate numbers, we would have been taking data on barometric pressure, temperature, moisture, humidity, et cetera, et cetera. But that's not what we were trying to show. What we were trying to show is the fact that the contention that some flat earthers have that you cannot have a gas pressure without a container is just total nonsense. So, for a 3-foot effective pipe length, we expected 0.045 and we got it. We expected 0.195 at 13 feet. It was a little bit high, 0.22. We expected 0.345 at 23 feet. Came out pretty close. So for a more or less qualitative sort of experiment, this shows exactly what we wanted it to show. Now, are you ready for some truths? Gas pressure can easily exist without a container. That is not a question. It produces a pressure gradient exactly like we see in our atmosphere. The pressure and the pressure gradient are being produced by gravity, fellas. That's what's doing it. An empty space is not only possible, it is simply undeniable. Our atmosphere vanishes slowly as you increase in altitude, eventually becoming that vast vacuum of space that's out there. So the next time a flat earther tries to tell you pressure can't exist without a container, just tell him this. So Gladys, you think we convinced them? Yeah, I think it'll happen about the time that happens. Hey, thanks for watching. If you enjoyed it, don't forget to like and subscribe, and we'll see you guys on the next one.